This is question 20 from the first CSAT sample paper. And in this question we're simply asked to find the limit as n tends to infinity of 1 over n plus 1 plus 1 over n plus 2 plus ... plus 1 over 2n. So if you want to have a go at this question yourself, pause the video now. Okay, so this is the kind of thing that will take a long time if you try to do it algebraically, but they do provide a hint. They say we're intended to use graph sketching, and at some point we want to use a fact about the limit of a function of a fraction of two linear terms. So first of all, let's try and think about the graph sketching bit. How could we possibly relate this to a graph? And you do have to be a little bit creative, but I think what they were going for was this. We've got all these 1 over something, so it makes sense to think about y equals 1 over x, and then think about what this looks like with respect to that. So let's draw y equals 1 over x. And we've just got the values at n plus 1, n plus 2, n plus 3, etc. up to 2n. So that's why I've just drawn these straight lines. But then I've added these dotted lines. Why have I done that? Well, because the straight lines make me think of approximating the area under the graph between here and here. Or actually between here and here, because we're drawing the right angle to the right of each line. So if I just complete a rectangle, we could do it with a trapezium, but it makes it more complicated and it doesn't change the answer, so I'll do it with rectangles. If we just complete each of these rectangles, all the way to 2n plus 1, because that's to the right of 2n. As n goes to infinity, what's happening? Well, the curve's getting flatter and flatter, so these rectangles are approximating the area under the curve better and better. Because bear in mind, the left-hand side, n plus 1, depends on n, so it's going to move further and further to the right. So our leftmost point is going to be further and further to the right, so the curve's going to look more and more like this flat bit, and less like this curved bit. So we're approximating the area better and better. And it's also worth pointing out, what's the area of each of these rectangles? Well, this distance here is just 1, and the height, as I've drawn it, is, because this is the function y equals 1 over x, is just going to be 1 over n plus 1, because that's the value of y when x is n plus 1. And therefore, this sum is equal to the sum of the areas of the rectangles. So the area of each one is, this one's going to be area n plus 1, this one area n plus 2, etc. This one area 2n. And as that approximates the area better and better, it's approximating, i.e. tending towards this integral, the integral of 1 over x from n plus 1 to 2n plus 1. And why is that useful? It's useful because the other part of the hint talked about the limit of a function of things that look like this, or a fraction of things that look like this. And when we integrate, we're going to get log, so we're going to get log of something, so it makes sense we'd have to use that fact about the limit of a function. So now let's try and manipulate this. When we integrate, we just get log of x between n plus 1 and 2n plus 1. So I'm getting log of 2n plus 1 minus log of n plus 1, so I just get log of the fraction using log rules, so I get this. Bear in mind, I don't need mod signs because I know the inside is positive. So now we're interested in what happens to this as n goes to infinity. So we know this is tending to this, but we can still figure out what this is tending to, and then they tend to the same thing. So as n goes to infinity, the top and bottom are going to infinity. But you should know how to, let's ignore the log for a minute, you should know how to calculate the limit of the inside. So we just divide top and bottom by n, we get 2 plus 1 over n over 1 plus 1 over n, and these 1 over n's are tending to 0. So the limit is just going to be 2 inside. And the hint we're given basically says that in this case, the limit of log of this is log of the limit. So it's going to be log of 2. So this tends to log of 2, i.e. the initial sequence we were given tends to log of 2. So this is our final answer.